Hello team, today's challenge is Rook and Bishop Attack, which follows up on yesterday's challenge, which was just Rook Attack, right? The rooks being the little castles, they go in a straight line for as long as they are allowed to. So for as long as they aren't blocked. From A1 to A8 or from A1 to H1, all those are allowed. The bishops we're adding today go in diagonals. So they can go from something like A7 to B8 or A7 all the way down to G1, or if they were on H1, they could go all the way across the board to A1, right? So working on the diagonals, and we are going to sort this out. Now, one thing that I wish I had done in yesterday's challenge was normalize the data. I didn't look back far enough in my notes, and I noticed that I already had another challenge called the Knight Moves Challenge, where I did something very clever by converting these letter number combinations to XY coordinates. And then everything just becomes math at that point. So we normalize the data and do the thing. But before that, we still want to make sure that it's on this board, right? We still want to check that. Otherwise, they could send us to, say, H9, which doesn't exist. We don't want that, okay? So we're going to borrow a little bit of yesterday's and a lot of that Knight Moves challenge, okay? Right here, starting with the bit from yesterday, okay? We're going to call this is legal position. So starting with a function, okay? Is legal position, brilliant. And we will just send the position in, okay? From here, we return a regular expression. And again, I don't really care if it's uppercase or lowercase, so we're going to skip that for the moment. But right here, we have that A to H, and behind it, we have 1 to 8. And then we test on the position, okay? This makes sure that we are somewhere on the board, right? That's all this is supposed to do. So we can grab this is legal position, go down here, set up an if, just like this, if legal position rook, or is legal position bishop, just like this, spelling it right. Then return, sorry, not return, throw new error. Nope. Okay, seems like a good one. This is actually backwards. Okay, we want to make sure that it is not a legal position in order to get into this conditional. So, a couple exclamation points. Excellent. This isn't actually going to do anything for us today, but I really like protective, defensive code. Okay, that's what this is. Defensive code in case somebody gets a little bit wild later on. Okay. The next bit is getting those coordinates. So this comes from the that Knight Moves challenge. Okay, we go const the rook chords like this, and we're going to set up for chess to chords. Okay, so sending in the rook like this, we're going to do the same thing with the bishop. So we can go and change this to bishop and bishop, just like that. Excellent. Okay. A function that we haven't created, so let's go and create that function. Changing rook to position just to make it more useful, and spelling things right. Here we go. Excellent. Okay. So for this, we want to do something. We want to return an array. And this array is going to be, I'm going to say XY coordinates, but it's not, because when you think about this being a matrix, we always do the Y first, right? We always do the rows first before the columns. So I'm going to set it up as YX coordinates, right? Just to match the matrix. It does start down here, right? If you look at the chessboard, the chessboard does start in the bottom left corner. We're going to ignore that today because it doesn't actually matter for us. If we assume that this is A1 or this is A1, the math still works, and we don't have to flip the board to do that. Okay. So right here, we start returning things, and that's going to be that position, just like this, at 1. Okay. So we get that second one, which is the number, and we subtract 1 because it's 0 indexed, right? If you didn't want to do that, if you wanted to keep it 1 indexed, you can get rid of this. But again, normalizing the data. So let's keep it in a format that JavaScript will actually recognize, okay? The second bit is that position, if I can spell it right, there we go. And we're going to do char code at, okay? So the character code at 0, okay? That's going to give us a number. So for the capital A returns 65, right? So what we do is we subtract 65 from this to get a 0 index. Now, there is a catch in here, something that isn't really going to affect us today because they only send through capital letters. But in my test, I tested for lowercase. And so the thing to do here is just to quickly lowercase or uppercase everything, just to be sure. Okay, again, defensive coding. So right here, I'm going to say POS. That's going to be position dot to uppercase. Excellent. Okay, and then we replace position, these two positions, with POS, right? So we've done a little bit of defensive coding here, a little bit down here, and now we have those YX coordinates, right? It's the rows before the columns, okay? With that, we can start to test things. So right here, we test if, what are we testing? Well, it's going to be can Rook attack, okay? So can Rook attack, just like this, we're tossing in attack. We're tossing in the Rook, sorry, not the Rook, but the coordinates. So R coords and B coords, excellent. And if it can attack, then we return Rook, okay, lowercase. We're going to do the same thing for the bishop. So can bishop attack? That's sending in the bishop first and the rook second, okay? At which point this should be bishop, spelling it right. And finally, if we don't catch on either of those, we return neither, okay? So doing this work, we haven't created either of these functions, so we're going to go and do that right here. Function, getting it done, changing these names, okay? So this can go back to being rook, and this can just be other, which makes it more flexible, right? In the future, if we do this and we're testing on if we can attack a knight or the queen or the king or even a pawn, right? Whichever those are, we can toss in those coordinates and see if the rook can attack. That's the whole point of this function, okay? So for that, we are going to return what? Well, it's going to be similar to yesterday's, where we compare the first positions and the second positions, okay? So we have that rook at 0. That's going to be equal to other dot at 0, or the other one, okay? So go and grab all of this just like that, bringing it down, tabbing it in, making it pretty, grabbing both these zeros and changing them to 1, okay? So if the two y's are equal or the two x's are equal, then yes, the rook can attack, okay? That's the whole test. Now, if going back here, grabbing the bishops, okay? So same thing, function, can bishop attack? We're going to change these names, bishop and other, because again, it doesn't matter, right? The bishop could be attacking anything. Now for this one, the curious thing here, before we get into it, is if we're at position A1 as an example, okay? Well, this is 0, 0, according to our coordinate system, 0, 0. Technically up here, stay with me for the metaphor, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, even numbers, right? The differences between the two x's and the two y's are always equal. And that works anywhere. So if I was at, say, B1, right? B1 being 0, 1, that makes this 1, 2, 2, 3, 3, 4, so on, etc. So if I do the math, 0, 1 to 1, 2, well, if I subtract 1 from 0, that's 1. 2 from 1, that's 1. 1 and 1 are equal. It's the same if we go backwards, right? This would be what, 1, 0 instead of 0, 1. So 1 minus 0 is 1. 0 minus 1 is minus 1. We don't care about the signs. We only care about the numbers. So that's still 1 and 1. So if we do a little bit of math and then just compare the X and Y differences to each other, then we've solved it. Okay, and that's what we're doing here. So back to the code. I'm going to grab this just to save myself some stuff. And we are going to jump into this, okay? So const, whoops, A and B. Not great names. Pick some better ones if you want, but for this, you'll see A and B is probably the best names that we could come up with for this, okay? Unless you're doing like delta X, delta Y, or something like that, right? So down in here, very similar thing where we take the rook, sorry, not the rook, but the bishop, just like this, at 0 and subtracting it from other, okay? Now that could return that negative number, which means that we should wrap this up and send it through math.abs. Excellent, okay? At which point we do the exact same thing for bishop at 1 and other at 1, okay? Now we do the comparison. So return A equals B. And that is it, okay? That's, if we've done everything right, that should do the thing, and it absolutely does. So lots of little mini steps in here, but hopefully this is making sense. The first thing that we did was we checked, and we because of how we're checking, we were able to simplify our regular expression quite a bit from yesterday's. If you watch that and you're like, oh, that's very complicated, well, hopefully this makes a lot more sense, okay? And then using that, if it's not on the grid, we throw an error, right? Because it's not a valid chess move, right? That's basically the long and the short of it. But this will never catch in today's test because they didn't give us any test for that. Again, more tests for the win, right? The second thing that we did was we normalized that data, okay? So instead of using the letter number, we converted that to a number system, okay? In this case, Y and X, because of the nature of matrices in JavaScript, right? The way that we access things inside of JavaScript. Otherwise, technically, this doesn't matter. I could actually flip this around, and if I added a comma here, it still works, okay? So if you wanted to do X, Y, you absolutely can. My advice is stay with what JavaScript actually likes, just in case you have to pass this around or use this to re-access that square on the grid, okay? But with that, moving on. So we got the chords and we got the chords for both these, for the rook and the bishop. And then we checked, can rook attack? Yes. Otherwise, can bishop attack? And we used some really basic math comparisons to get it done. We didn't need any special looping or anything like that. It just all works. But in order to get here, we did have to create 4 other functions, which feels like a lot, but they're all tiny. They're all easily testable, and they make our main body function really easy to read, hopefully. Again, this thing here, I like to inline things, right? Because I like how this reads. So if this, return, return, return. But if you don't like this, if it's more comfortable to do this, it still works. It doesn't matter, okay? So if you notice that one, you're like, oh, I don't like how he's inlining the returns. Well, you can still add brackets. It's going to add lines to the length of your code, but it's still readable. It doesn't matter, right? It's all a preference. So do what you need to. I'm going to back this out, and there it is. Again, not every solution, but hopefully one good one. Okay, and I feel like that's what we've done here. And in fact, I feel like we've improved on yesterday's solution by normalizing that data, right? Making it easier to pass around and do stuff with, right? It's almost getting to the point where we should probably toss all of this into a class. I'm not going to do that today, but if another challenge comes up, say for the knight side again, right? Or the queen attacking in all directions, well, we're going to have to figure something out, are we? But that's a tomorrow problem. What do you think about today's, right? Did you like it? Did you hate it? Did you find a different way? Let me know in the comments. Otherwise, today this has been Rook and Bishop Attack, and I will see you tomorrow.